So hello everyone, welcome back to the YouTube channel Devotion of Knowledge. Welcome to the C++ STL playlist that we are currently learning. In the previous video, we got the in-depth knowledge of pair container in STL, and in this video we are going to have some pretty good knowledge, or we will try to have some knowledge of custom comparator function. Also in the previous video, we learned that how to sort elements of pairs in which the first element is in increasing order, and if the first element of any two consecutive pairs are equal, then to sort them according to the second element, which should be decreasing. We learned that thing by multiplying -1 value with the second element. But in this video, we are going to understand that without multiplying or manipulating the original data, how can we carry out the same functionality by writing some of the bunch of lines or couple of lines of code. Now, as you would be knowing, we used in the last video, we use this function sort v.begin, v.end. We use this function. It is also known as a custom or inbuilt sorting algorithm, and it is considered as one of the most efficient sorting algorithm for any language, because it is mainly composed of three algorithms, mainly insertion, tweak, and heap sort. Whenever the size of the any data structure that we are passing is relatively smaller, it uses insertion sort, because whenever the size of any data structure is relatively smaller, insertion sort works best in those cases. Now then, quick sort works in worst case when a particular data structure which is given is in already sorted form. So in such cases, whenever the recursive calls for quicksort are going out of some predefined limit, the algorithm directly switches to from quicksort to heap sort, which uses heap data structure in backend for sorting. So it is mainly combination of these three sorting techniques. Now, if I want to have some custom behavior, for example, I'm giving a pairs in data structure. For example, 3 2, 3 1, 5 2, 1 1, and for example 4 3. I am having this 5 pairs in my vector, and I want to sort them such that first element is in increasing order, and if first element of any consecutive pair is equal, I want second in decreasing order. This is the catch that we are trying to implement. See, this thing can be implemented in code using two ways, mainly by passing comparator function, or by using lambda expressions. We will be seeing both of them. This one is more interesting because lambda functions or lambda expressions itself is a very interesting topic, but we won't be going into too much detail because it will take a complete another video of lambda expression. If you guys are willing to learn lambda expressions, please write into the comments. We will make a complete separate dedicated video for the lambda expressions as well. So let us understand first passing comparator function. Let's move directly to our IDE VS Code. Here I have already written some couple of lines already, in which I have just declared some of the pairs that we are having in our vector. So now I want to sort this particular uh, pairs such that this first element should be in increasing order, and if the first element is equal, I want the second part of the pair in decreasing order. So we will write sort v dot begin v dot and we will be passing comparator function here CMP, or you can write any another name you want, but generally we are writing comparator function CMP because it's more convenient to write or to give a name to a function based on its own functionality. So here the return type should be boolean. We'll take pair of int comma int a, pair of int of b, because whenever it is implemented, we are comparing, as you can see, we are comparing these two things at a time. So whenever the first element is equal, it will compare second element. So we should have the whole pair as a parameter of the function. So here we are passing pair, means both the pairs. Now please remember, if we want to swap, return false. Please remember this catchy line, or it's a punchline for understanding the comparator function. So if the first element is not equal, means if a dot first is not equal to b dot first, in this case a dot first should be less than b dot first. Am I right? So if a dot first is greater than b dot first, in this case swapping should be done or not? Am I right or not? In this case we will return false. I am repeating again. If you want to swap, means if you want to swap the corresponding elements, return false. So if first element is not equal, in those case we should be having first element smaller as compared to the first element of the second pair. So if they are greater, it is violating our rule, so we will return false, otherwise return true. It was the case if first element of corresponding pair are not equal. If they are equal, then we will bind this code into the else part, and if their a dot second is less than b dot second, means we are willing that second part should be greater first. So here if the first means second element of the first pair is smaller than the second element of the first pair, swapping should be done. So we'll just return false in this case, else return true. I hope the concept is clear. Cout it dot first, let us run the code. See, first elements are sorted in increasing order and second elements are sorted in decreasing order. Let me explain you the comparator function again. Please remember this line. If we want to swap, return false, else. This comparator function works differently as compared to other functions. If we are willing to swap, the return value of the function should be false. So if the first element is not equal, then we should have, means first element of the first pair first, and second first element of the second pair second. So if a dot first is greater than b dot first, it is violating, so we will be returning false, otherwise return true. And similarly, in a dot second part, we want the reverse of the initial one, so here we are writing second. Now let me give you a shortcut. If it, I know it feels messy to remember this, let me give you shortcut. Uh, return whatever you want. Simple. Return your condition that you want. For example, here I wanted a dot first should be less than b dot first. Simple. And here return a dot second should be greater than b dot second. If I run the code, output is the same, because see, whatever we wrote previously, it's a shortcut, because if a dot first is already less than b dot first, in this case we won't be requiring any kind of sorting, so it will return true. And if that particular law is violated, it will return false and swapping would be done. Now this was the first way of writing this thing. Now what if I want to uh, use lambda expressions instead of this thing? Let us do it by writing lambda expressions. Lambda expressions are written in the same line in sorting function. Its syntax is like this. First the square bracket will come, then data structure will become that we will be getting, and this curve bracket. Here we will be passing by reference to avoid extra memory usage. So we will be writing and we will be writing the same things that we have written upwards. If a dot first is not equal to b dot first, return a dot first less than b dot first, otherwise return a dot second greater than b dot second. Simple. Let us run the code. As you can see, output is the same. Now let me explain you this lambda expression, not in depth, but let me explain you the basics, that how it is working. First of all, we are writing this square bracket uh, parameters in the function. Now this particular bracket is known as capture clause. It defines the scope of parameters that we are taking. Here the parameters that we are taking were already defined into the same line of the sorting function, so there was no need to write anything inside this clause. But if you are having, for example, some map or some vector defined above, somewhere above this sorting line code, so in such case, for example, the vector name is v, so we should write v here to access that particular vector inside this particular scope of this lambda function, because lambda function is from here to here. So to access this particular vector, to access that particular vector that we have defined above inside the scope of this lambda function, we have to write v here, or any other variable that, for example, x, y, dot dot, anything you want to include inside the scope of this lambda expression. You should be writing inside this capture clause, because the name only suggests it captures the scope of the elements or any data structure or container that you are passing inside this close or this bracket will be captured for this particular line of code or between the scope of this two curved brackets. We are not going into much of the detail of this lambda function, because itself it's a very interesting topic in depth, and if you guys are really willing to understand lambda functions, please write into the comments. We'll make complete separate video on lambda function. So here we have written lambda function to carry out our functionality, custom functionality, and previously we defined a complete comparator function above, as we have defined here, to carry out the same functionality that we did using lambda function. So I hope guys this is clear for this video. We have understood enough content that we require for ascending or for understanding a comparator function. Here you can also modify things according to your needs. For example, in first part I want decreasing order, and in second part I was decreasing order. So whenever we run the code, output will be accordingly. as you can see. Let me save the code first. Okay, output is accordingly, as you can see. So here I think we should conclude the video. We'll meet in the next video very soon. Till then, stay tuned with the channel. Till then, keep learning. Goodbye. Thank you.